everyone, and welcome. We definitely appreciate you joining us. Members, thank you very much for supporting us on Patreon and on YouTube. Definitely appreciate it as I'm finishing up the edit on the slag video. Uh, it is a major accomplishment. It's going to be a major project, and it's coming out really well. Mike did a great job explaining this stuff. Our conversations flowed back and forth. I'm adding extra video and media in there, so that video is going to be rich and deep, and it really is going to be what Sue wanted it to be. The touchstone video for slag, for rock hunting, meteorite telling. So I'm really happy about that. So your support's helping me get that done. So I appreciate it. We have a few things that we are going to be talking about today and showing off. Some serious, some not serious. One thing is always, we're going to start from the serious and go to the silly. So, of course, Pat is first. Like, who didn't see that coming? Pat, you were, how the hell are you, buddy? Let's just
I'm
start off.
doing well.
Good.
And finally got the wire saw back up and working.
Hmm.
And I was experimenting with some new wire that's a little smaller. It's 0.25 millimeters.
Don't
And
name this material. Don't name this material type yet, please.
okay. And so this is the first full slice that came off of the saw. And yeah, it's kind of odd stuff and a little out of my comfort zone. So there's the full slice, and here's the inside of the end cut.
It
And
it looks really interesting. I'm going to interject and interrupt for a second.
sure.
Does anyone in the crew who didn't look at the Google sheet and know what he's presenting, does anyone have a guess at what we're looking at here? Because I'll be honest with you, if I looked at this, I don't really know if I'd be able to 100%. Well, I know for a fact I wouldn't be able to pick it out 100%. Does anyone have a guess as to an overarching classification? Mars, Jules, no.
Well, I see
The
chondrules, but you know,
So it's a chondrite. All right. Thank you. What
yeah.
type of chondrite?
My thinking is an LL, maybe five,
Yeah,
four, or three, something like
it's
that. But I don't see any iron in it. But there's a lot of white matrix.
you picked out a few, not knowing what it is, and dissecting it like that. Pat, do you agree he picked out some of the key features? And why don't you break it to us? What is this? And
Yeah, so yes, those are chondrules. I think at least most of them. This is straight off of the saw, so no lapping or anything yet. And one of the odd things about this one is how few chondrules there are and how much matrix
yep.
there is. That's a major clue. And the color and consistency of the matrix is another major clue.
Hmm. So this is a carbonaceous meteorite, not
It
an L
is
or an H.
it is
Um,
carbonaceous, yeah.
yeah. And Art, you have a guess?
Well, I was just picking out something that was interesting on the bottom. It looks like a line
Mm,
going all the way across the bottom.
yeah.
Yeah,
Okay.
that's actually the fusion crust.
Are you
Oh,
serious?
This
Wow. Huh.
okay.
Well,
Okay.
very nice. So, do you know for a fact that it's unclassified but likely a Karunda type?
Yes, it's likely to be a CK. And if I flip the end cut over and let you look
Oh,
uh, at the other side, and I apologize, it's not in focus. It's not flat, but you can see that you can see a few chondrules here and there, And the matrix is a very characteristic greenish, olive drab uh, sort of color. And I've had this one for a long time, but it took me a while to getting around to cutting it. Uh, and I'm not certain, but the thing kind of top center there that has a
Yeah.
bluish cast to it, that could be a CAI. Although one of the odd things about CKs is that they have a lot fewer CAIs than the other, CVs and COs and CR, or not CRs, but
Do you,
CVs.
do you think that may be because they formed further out from the sun, maybe?
Yeah, so there's a bizarre thing about two facts about carbonaceous chondrites that are very counterintuitive. These things formed in a very, very dusty area, we think outside the orbit of Jupiter. But in general, the carbonaceous chondrites are rich in CAIs. And CAIs were the first solids in the protoplanetary disk, and they formed very close to the sun. So there's some mechanism that everybody argues about at Meteoritical Society meetings of how the CAIs got out there to be accreted up in uh, carbonaceous chondrites have a lot of very low temperature minerals in them that if, they had to have formed and existed in a low temperature, otherwise they'd break down. Uh, and it's also very dusty out there, which both of those things are very interesting and fascinating.
Thank you, Pat. I appreciate the science being brought. This is I'm not surprised someone said L material because it does look very L with the light gray matrix and the amount of matrix and the fact that there's no real well in this one there, but there was really no visible CAIs and very round chondrules. So yeah, very interesting stuff. And I'm glad to see that you found something in your house to cut. I know it's a struggle these days.
All right. Thank you, Topher.
Thanks, dude. I appreciate it, man. We are going to remember we're going from serious to less serious. So, no. Let's see here. I don't have very much science to share, but I want to show you guys a piece that I showed last week, and I couldn't zoom in. We already identified it as a Timamoon 003 or 002, I think. It's the Diogenite. And if you can highlight my camera pad, I'll go ahead and show it off.
Gotcha.
Okay. Yeah, so I can finally zoom in today, which is super nice. Perfect. Okay.
Man, there's little bits of everything but the kitchen sink in there.
Yeah. I'm really not a fan of these cracks right here because this is the fusion crusted part. So if I did any cutting at all, it would break off. But yeah, it's really, really unique, beautiful stuff. And here's the fusion crust.
Nice.
Yeah. Yeah, so this is, oh wow, in that little hole there's some more fusion crust. That's cool.
Wild.
Yeah, this is really, really interesting.
It's interesting in the fusion crust, you could see these white inclusions that
Yeah,
apparently didn't get burned or they just stayed white.
yeah, that's the white inclusions you're seeing
Yeah.
here.
Hmm. So sometimes we see the fusion crust get ablated a little by blowing sand in the Sahara, and then oftentimes we'll actually see desert varnish build up on the surface as well. And so this could be a combination of a couple of those factors. And sometimes the harder material, will show proud in the fusion crust, or higher temperature, harder to melt stuff.
Right.
All right. Well, that is my space rock that I wanted to show off. I showed it off last week, but I wasn't able to zoom in, and you weren't able to see it as beautiful as this. So I've now paid it the respect that it deserves. Um, Pat, if you could unhighlight me, please.
Mhm.
When we come back to me, my show until later on is going to be um, Moldavite, believe it or not. Yeah, I'm going off on. Yeah, you figure you don't really expect me to be showing off Moldavite, but I was going to show off some stuff today, and I had to move a little pile of Moldavite aside. So I was like, you know what? I'm showing Moldavite today. Um, we are going to go to talking about glass. Ooh, how about that segue, Dave? What do you have for us, Mr. Pinsky?
What I have is thin sections of Abba Panu meteorite that I was just playing around with my, oh, there we go. I was playing around with my new little digital microscope, and yeah, astronomy, meteorites, it's all the same stuff.
Can I ask your age one more time, sir? No.
Slightly older than you.
Yeah,
Okay.
Yeah.
So here is my favorite. I'll show you my favorite of the first, the four that I'm going to show, because it's just, oh man, I'm so busy trying to make it look really cool and nice that I'm not spending time trying to learn how to identify the minerals. The one thing I do know is, so when you see stuff like this, it's usually barred olivine, and that's an easy one to determine. But there's a mixture like in here of this purple and blue, and there's green here, and I don't know how you determine uh, the minerals and such. That would be
Yeah, so
really,
so at a first cut,
yeah.
the ones that are the really bright saturated colors are usually olivines, when you're looking at an ordinary chondrite. And
Yeah.
when you see the striped action like that, that is some sort of a pyroxene. And the pyroxenes tend to be grayscale, white to gray to black. And when you
Oh,
see the
okay.
little stripes in them, that is twinning. They actually call it polysynthetic twinning, but it's where the crystal lattice grows and alternates back and forth on the optic axis. And so you see the striped.
Oh, okay. Because so in other words, these in here are olivine, and they're
Yes,
just facing different ways, so you're seeing different colors.
exactly. Yeah. And
Okay.
and
Yeah.
that chondrule, which has a weird appendage on top,
yeah.
but that type of a chondrule will be called a porphyritic olivine chondrule. And porphyritic is a $10 word for large and small crystals.
That is a $10 word, because it'll cost me almost $10 worth of brain power to try and remember that. Um, uh, and then, so then you have this one right here. They look, maybe I don't know what barred
Yeah,
olive.
No,
I,
I think,
I would think that's a Bart Olivine.
yeah, I
Yeah,
think it's a Bartolomeo. It's not a super organized one. It's got different plate thicknesses, but remember that the Bartolomeo chondrule is a stack of plates, and
right.
depending on how the thin section was cut, they might be wide or skinny or.
That's true. You may just see one plate, and they're actually piled on top of one another, and some you'll, cut from the side, will you see all the plates.
Mhm.
That, yeah, okay. Then there's another interesting one here where you have
Ooh.
nice blue things, and then you have a kind of a golden uh, pieces there. I'm telling you, it is an amazing thing of the variety that you see in every chondrule. They just look different. They're like
Yeah.
snowflakes.
Mhm.
Especially
And
you're lucky to have a thin section of Abba Panu
yeah,
because Abba Panu, as you noted in your sign up, is an L 3.6 projected. So
yes,
it is a low petrologic. It has a lot of beautiful chondrules in it. And like here's almost a like Pat said, almost a perfectly round one that has a blow up at the top.
yeah. Oh, this thing right up here.
Yeah.
Well,
Let's see.
maybe that's the reason it's 3.6 instead of lower is because there's some pressure effects on some of these, and that might be it. Because I do know, thanks to Pat, obviously, is when you see the very low ones like 3.2, 3.15, and such, you get some very distinct boundaries, dark
Mhm.
boundaries around the
Mm.
chondrules, and I see less of that here. They
Yeah.
seem to starting to get slightly disorganized.
Yeah, now there's a couple things going on there. So the dark rings of matrix around the chondrules, that's characteristic of about 3.5 or below.
Right.
And then there's the cluster chondrule
There you
part of
go.
it, where the chondrules were still a little squishy and didn't retain their spherical shape and got squished into uh, odd shapes as they packed together.
Yeah, that's another thing that I also look for. And again, thanks to Pat. We make fun of him, but there's a lot of knowledge and information in there, and it takes time for it to start to get inside the brain,
Yeah.
and so to speak. So I'll go to the next one. There is a really cool one right here.
Oh wow.
Ooh.
Yeah. So this one looks like it got squished a bit.
Yeah, and it's a barred olivine chondrule and quite possibly broke a broken piece uh, of a barred olivine chondrule, but it's very pretty.
Yeah, yeah, it is. There's a lot. I mean, there's a lot of plates in there that are just really close and really interesting stuff. Then there's something like this here. Again, you just never see the same stuff in this one. Really, this is one of my favorite thin sections because there's just so much going on in this one. Um, and then let's get to this one. So again, more of the same thing
Mhm.
here. This looks like some of those that are starting to come apart a little bit. It's in here, but again, it's not as organized. I'm really beginning to understand where the 3.6 comes from as opposed to
Mhm.
3.2. Uh, and let's see. Yeah, look at all this stuff here.
Mm.
Yeah, really interesting. And then the last one, I think, is the peroxene.
Uh-huh. Yeah,
Yeah,
that's either a radial pyroxene, but I don't really see it focusing to one point, so I think you'd call that one a cryptocrystalline
mhm.
pyroxene chondrule.
And then it's squished up to a whatchamacallit, barred, I think,
Yeah,
olivine. Yeah.
very scrambled up barred olivine.
Uh-huh. And then this one's an interesting one too, I noticed.
Huh.
It looks like it's got a crust or a coating on it, and then inside you have the colorful stuff going on in there. So I would
Mhm.
imagine that's olivine also. But what would this stuff be around it?
So one thing that we know
Shielding.
happens, and it doesn't show up in all chondrites, but shows up especially like in a yende, is you
Yeah,
wind up with a chondrule that cools and it's
yeah,
free floating in space. It's not part of a rock yet, and it accumulates dust on the surface, and that dust is mostly silicate sort of stuff. And then it gets a small heating event, enough to kind of center or semi-melt that material onto the outside of an existing chondrule. And in Allende, Dr. Alan Rubin has shown chondrules that have as many as 5 layers of stuff built up on the outside of a chondrule.
Wow. So what really is so cool about that is we're talking about chondrules and material that is, just by the piece, floating around in space, collecting dust and material around it before it even accretes into a body.
Yeah.
And that is literally the very beginnings of the geological processes in the solar system, which is absolutely amazing.
Yeah.
That is something. Now, I have also seen chondrules that have metal
Yes. Yes.
doing
And
the
it's
same thing.
basically the same mechanism, and then and of course we call those armored chondrules. And
Yeah.
sometimes there's armored chondrules that have iron sulfides as a layer around them, but it's all basically the same process, we think.
Absolutely. Okay, well, you see, this is why I got into this from the very beginning.
Nice.
This is the stuff that really, really, really does it. And I'm glad. I appreciate that information. That's really, really
Yeah.
good.
And David, I think it's worth pointing out too that this is done with not a terribly expensive digital microscope and some sheets of polarizing film material.
Right. The one thing that helps, if anybody's going to go out and do this, I also bought that attachment that has a polarizing filter on the lights and that one in the middle for the lens. So
Yep.
you can also use that for reflective polarization. So I
Yes.
bought the film for the below the slide, and then I use this in front of the lens, and that works out really, really well.
Cool.
But my advice is you tape that film down really well, because it likes to lift up the slide a little bit, and you really need it flat down on there really nicely. But yeah, that's it. I didn't spend a lot of money. I'm getting way better results doing it on the digital microscope than my, the one that use visibly, and I can attach a camera to it. But for some reason, the quality just isn't there. I don't know why. I have a great camera, and I think it's the attachment that attaches to it. It's just not working as well. I
Yeah.
get them, but this is so much better, and it's quicker and easier.
Awesome.
Anyway, so that's what I got.
I appreciate you sharing that with us. And our first two contributors, both Pat and Dave, are paid supporters of the channel. So thank you both very much for your membership. We'll go to another of our supporting members, Mr. Well, no, I'm gonna continue. I called him Mr. I'm gonna continue. Mr. Chris Sanders.
That's Doctor you, buddy. Everybody else call me Mister, but you got to call me Doctor.
Yeah, I have a feeling you're gonna show us something that doesn't exist.
Ain't nothing but a G thing, baby. That joke will make more sense here in a minute.
It was still funny even before.
There we go.
So ignore the stuff in the background. I was taking fancy pictures. So looking at a chondrite here, pretty normal looking chondrite from the outside, but it gets a little crazier when you flip it over.
Ooh.
So a lot of metal in this one. This is the provisional name is ZLI 167. I think we've seen this here before on the channel. I think Pat might have a piece of it. This is the end of it, and it is not currently yet classified, but it is a member of the working group for the proposed G class of chondrites. So the idea behind that being that it has, I think a couple things, probably the biggest thing is it has a greater amount of metal than H chondrites on average. Pat can correct me if I'm wrong on this, but I think with G chondrites, the threshold is somewhere like north of 20% is the idea.
I know with H is I think it's 17 to 23, so I would hope this would be higher.
Yeah, and I think what I saw, I think was like maybe like 22 to 26 or something. I mean, there's only to my understanding is for it to be a class, it has that there's a working group and you have to get, I believe, 5.
Yeah, we got to be close to it though now.
I know
Like,
2 of them. One of them is Grosvenor Mountains, 95,000 something, which is an Antarctican meteorite, and one is Sierra Gorda 9, which is a Chilean meteorite. So I know of those 2 plus this one. There may be a couple others that I don't know about.
yeah, I know that there's one other one because I have it behind me. But yeah, there's got to be like 4 or 5 now, man. But if you can, Chris, show us some things on this that like the metal veining and the metal. You talked about the metal content, the higher than usual metal content, but the orientation or the where the metal is and how it's aligned in veins as well as specks and flecks.
Yeah, you can see that here now that I've zoomed in. Figure out where my thumb is right here.
Yeah.
So yeah, it has veins, and of course, when we talk about metal, metal can be in meteorites in a lot of ways. There's free metal, which is what we see here, and then there's bound metal, which is not metal you can actually visibly see. This has some of both certainly, but it's a lot of free metal. You see the flecks and specks everywhere, and then you see these veins and little blebs everywhere, and it's just kind of all sorts of interesting orientations and ways that you don't normally see in other chondrites, not to this level at least.
Is the metal veining, is that shock melting?
Well, I assume this black in here is the result of shock melt, right?
Yeah, and I think a lot of the metal veins on these are about melting as well. But the other meteorite, there are a number of meteorites, and Topher has one of them that are classified as OC4s that actually have little metal veins around each individual chondrule. And those, it's been proposed that those would be part of the now grouplet, but hopefully someday full-on group of the G chondrites.
I just put on the macro lens. Get a little closer.
Oh yeah, you can definitely see the shock darkening in the olivine.
I see the shark too, man.
Down low. Yeah, the G chondrites are very interesting, and there's even a political thing about it too. Grossman wasn't happy with so many write-ups talking about G chondrites, and so they were kind of edited out. And the proposal to get the group together is going to get a lot of scrutiny.
Yeah.
My only problem with it is that we're going to go from L, LL and L, very low and low metal, H, high metal, to G. Which I know comes from the first one is because it's from Grosvenor Mountain or whatever, and the G comes from that. But also, like, I don't know, seems like there would be a better. Not everything has to be named after the first one. I don't know. I just feel like there's a better way to go about that. That's not as confusing.
Yeah, so we also have the K chondrites, which are from Kangari is the type sample for that one. And these proposed G chondrites differ from the ordinary chondrites in some other significant ways as well. Oh, look, in that vein, you can see a mixture of metal and sulfides.
That's beautiful. Yeah.
And metal-filled cracks running off in different directions.
If I remember correctly, I think I remember a comment of someone knowledgeable that said some of the metal can actually be pushed through and through the rock material with shock. With the shock impact, it can actually force the metal further and movement than the silicates, and they actually will escape and cause and see what we're doing here, where they're
Yeah.
pooling together.
Yeah, and the melting point of the metal and the sulfides is a lower temperature than the melting point of the silicates, generally mostly olivine. And so you can have a situation where you have enough energy from the shock to melt the metal and the sulfides and extrude it into cracks.
Some good stuff, man.
And
Yeah.
as you might expect, it is it's very magnetic.
Oh, Jesus. Hold on. This deserves a spotlight. Yeah. Jesus Christ. We got Gallagher Jr. here, everyone. I was polite because I could have said Carrot Top. Yeah. Hey, I appreciate you sharing, bud. Thank you very much. Bringing the science and the new style. Talking about style, we have Anthony in the house. Anthony spent a little bit of time this weekend at a rock show in Ventura, California, with someone I know of through the meteor community. I've never met him, I don't think. And you wanted to tell us about that a little. Well, whether you wanted to tell us about that or not, would you please? And then also, you wanted to show some wire wrapping and some meteorites and stuff. So the floor is yours, buddy. How are you?
I'm good, Topher. So yeah, I had the chance this past weekend to help out my friend Michael Santos. He's a meteorite vendor. He's been in the business for like over 40 years, and he goes around the shows in California. He's one of the only, I think he's the only meteorite vendor in California who goes to the shows. So I met him last year and we just hit it off, talk about meteorites. It's a fellow meteorite buddy,
Yeah.
and we kept in touch. And earlier this year, he asked me to help him out at the booth that he was going to be vending at. It was also in Ventura. And
How'd you feel about that? Was it a little intimidating? Because people are going to be asking questions.
Yeah, the first time I did it, it was a little intimidating, but like after watching him, like field questions, I pretty much picked up all of what he said.
Yep.
I was listening very intently, so then I could repeat it to people. And then, I know a lot from all of you guys here in the Bolide crew,
Sure.
you know what I mean? So I'm not coming in completely cold.
Yeah.
So he sets up his table pretty logically, according to the three main groupings of meteorites. So it just went spatially down the table: stone, stony iron, and iron. So we could kind of explain planetary core material, planetary crust material, and then the cross section between the core and mantle for the stony irons. But I had a lot of fun, getting to talk to people who don't really know a lot about meteorites, which I think is most people who come into those rock and gem shows. You don't get a ton of folks who are super knowledgeable or even know that you can collect meteorites. So it was a lot of fun blowing people's minds. You know what I
Yes.
mean?
Yep, I hear you,
Like,
dude.
and he had one nice piece of Imalac. It had to have been like 20 grams at least, but it was our showpiece to put a backlight and just blow people's minds
Yeah.
with the crystals, And yeah, a lot of fun. And of course, when I go to a rock and gem show and if there's meteorites, I gotta get some meteorites,
Yeah.
okay? So let me just show you what I got. Last time, what I did is I just kind of picked up, picked out stuff as I was going through the show and I set it aside for I'm gonna buy this when I go home, okay? And let me just go to my other camera here.
And while you're doing that, I will pause for the cause and say that Dr. Chris Sanders and Anthony are both paid supporters of the channel. So we definitely appreciate both of your support.
No problem, Topher. Happy to do it. So much fun.
Thanks, man.
Okay, so as you can see, this is nothing crazy. We've all seen, I'm not even going to try to say the name. Here, I'll let you guys look here. You guys see that?
Kaalijarv? Kaalijarv. Yeah,
Yeah.
from Estonia. Okay.
Yeah, I'm not even going to try, bro.
Wow.
But anyways, it's a nice, 1AB. We've all seen those before. This one was particularly shiny. Let me see if I could just move it a little bit. See if I could get some.
Wow, it's pretty big. It looks big next to your thumb, man.
Yeah.
And it's
Yeah,
got
it's
a nice
18
edge.
grams. It's 18 grams, right? And the reason why I got this is so you can have a reference for what I'm about to show you next. So this next one is a piece of the same meteorite, but let's look at the difference here.
Whoa.
Oh,
Yeah.
wow.
So this is an impact warp Wittgenstein pattern.
Yeah.
And
That's
I'm
super
a
cool.
fan of the weird and unusual when it comes to
Yeah.
meteorites. And let me see if I could just give you a little twist here. You
Wow,
could
that's
really see how that original pattern just got squished and pulled together. You know what I mean?
Mhm.
that's crazy, man.
Yeah, I really love this piece. When I saw it, I just had to have it. And I'm not a huge fan of meteorite slices because I live on the West Coast, but for this, I was willing to make an exception.
Wow.
Very cool.
All right,
Did
so
did he say that the whole stone was the same way from the impact?
yeah,
Wow.
yeah, it was just another
That's
stone.
very cool. It
All
does
right,
look like you could be able to get it and just stretch it out. You know what I mean?
yeah, totally. Like spaghetti almost.
Yeah.
All
Well,
right, I got
Estonian
one more
iron.
thing.
Thank you,
I
man.
got one more thing for you, okay? You guys know I'm an aesthetic collector. I love the way things look. And for those of you who don't know, I'm half Italian, so I'm partial to boot-shaped objects. So, without further ado, this is the boot. Let me get you a little light there. And this is an wedge cut of Gibeon. Let me see here. And it's so cool because there's this inclusion on the bottom that is right where the heel is. You know what I mean? It's perfect.
Yeah.
Check it out.
Nice.
Wedge.
Oh,
Yeah.
wow.
And that is Gibeon. We all know of and love Gibeon, right?
Yeah, man. All except my Gideon. I don't like my Gideon. It won't take an etch. Yeah, yours is when you had the light at the angle on there, you could see almost every little striation of metal grain going through. That was really cool. Well, thanks for your report from the Ventura Rock Show. I appreciate it, and really cool to see you out there as an ambassador for Meteorites, because that's kind of what we all are. You know what I mean? So, I will dock you 2 cool points because I wasn't sure if you wore a Topher spin shirt or not, but no, the knowledge
It's
Bolide is
Dune.
okay. Yeah.
It's
Oh,
Dune. It's it's science fiction. That's the desert mouse from Dune.
Jesus. I have this. This is something that Roberto Vargas 3D printed for me because he says that the rabbits in Arizona look like they're all jacked up on drugs, and the ones where he lives in Connecticut are really cute and fuzzy. So he printed me an Arizona rabbit. Yeah. So yeah. Sorry. Thanks, Roberto. I actually have this on my desk right in front of me, and I look at it and it reminds me of you all the time. Bruiser, we're gonna step into a little bit of space exploration with you. You got some activities that you attended, huh?
Yeah, so last week was the National Space Society's International Space Development Conference. And I don't know about you guys, when I hear International Space Development Conference, I think it's going to be all business related, space industry. It's like there's nothing for me there, really. Um, and they did a Zoom a few weeks ago, and it's like, no, it's like there's a lot of other stuff. There's a lot of things you can learn. There are several different tracks of things that they were doing, from the moon, Mars, planetary defense, biology, living in space, um, putting um, data centers in space was one of the topics. Um, a lot of other things. Um, and I also saw that there were going to be several shuttle astronauts and one Apollo astronaut that was going to be there.
Cool.
So that last part I'm going to save for next week. And
Nice.
but just because I don't have anything to
Yeah.
really show right
Yeah.
now. One of the guys that was there was selling some books, and this is one of them. Hope it comes out. Yeah.
Ooh.
Apollo 15 Lunar Sample Information Catalog. That was published by the um, Lunar Receiving Lab, which we all know about. It's like a flip through, like, some of the pages, the indexing, um,
Wow.
some of them.
Wow. These are the actual friggin' rocks that they picked up basically by hand.
Yeah, and this is the catalog that they printed that other institutions would get. It's hard to see, but it was 3D, three ring bound.
Wow.
Huh?
And this copy happened to have been owned by the Lunar Science Institute, and
Cool.
it was also later signed by Al
Oh,
Warden of
Wow.
Apollo 15.
nice.
Jesus.
Nice.
So that's book number one.
That's sweet, dude.
So how much thinner was your wallet after book number one?
It actually wasn't that bad.
Really?
Because between book number one and book number two, so this is some of the scientific papers that were later written about the samples.
Cool.
Some data, just general data articles. Again, so this one, let's see if I can get this lined up. Was
Yep,
owned by the
Planetary
Planetary
Science
Science Institute in Tucson.
Nice.
And again,
Nice.
signed by Al Warden.
That's awesome.
Awesome.
That is great.
So actually, the two of them I got for 150, 160.
You're
Jeez.
kidding.
No,
That's
I saw that and I'm like,
yeah.
take my money.
Yes.
wow.
Yeah.
Wow.
Wow.
It was, that was like such a no-brainer. And I was like, and he had other stuff and I didn't have the time. He did have a lunar meteorite. But that I actually looked at and I said, nah, that's a little much for whatever it was. I mean, as we all know, it's like the prices of lunars have come down dramatically. So I think he probably, when he got it, paid whatever for it and was looking to get that back. But so anyhow, they had there are several books that are coming out from Hoot Gibson, Sally, Susan Killane, and Stephen Hawley, all shuttle people. And so one of the things that I do when I go, and I know that there are going to be astronauts there, and I know that they're going to be signing, I take a photo, NASA's archives. You can download the photos, and I'll print one out. Sometimes I'll print several out, and we see all these photos all the time. And the big question is, what are they doing actually? I mean, we always say, a picture's worth 1,000 words,
Oh no.
So what I've
Oh,
done is
hold on
when
one second.
I go and ask for, I get them to sign the photo and explain what they're doing. And I had several for Susan Killian. I had several different photos, and this is the one that she chose that she wanted to sign. Wait,
Wow.
over the others. And I was like, okay, why? What's this important about this one? And it's like on their first mission, which was STS-83, um, they had an electrical failure.
Ooh,
So they
fuel
lost a fuel
cell.
cell.
Ah,
So that's right now is what she's writing, all updating the emergency procedures because of that loss of the fuel cell.
Wow.
wow.
That, and it was such an important mission. I don't honestly remember exactly what it was, but they reflew the crew the next available slot that they had to do the same mission because they were
Wow.
up in space for a couple days and the fuel cell went. And if they had lost another fuel cell, they would have been down to one computer. And obviously, if they lost that, that would have been the end.
Hmm.
Um, so that was one. And then there was also Stephen Hawley, who was a mission specialist, and um, he was on the mission when they first launched Hubble, as well as one of the servicing missions. And so this is from the servicing mission,
Oh my
and
gosh.
you can see him. He's handling the robotic arm, and where is it? Where's my finger? So right here is one of the astronauts that's out there that's working on Hubble. And he mentions that he's like trying to maneuver him, and so he doesn't whack his head into the solar panel since they're really fragile.
Wow.
So yeah, because
Dude,
otherwise,
that's a great that is a great idea to ask them to put a comment on there of what they were doing.
yeah, it's not so easy. I've had some that have just said no and just
Sure.
sign their name or whatever. Um, but I've got like 20 of these things, I think. And so I'll show them, well, here's what some of your other astronaut friends have done.
Peer
Um,
pressure does exist in NASA too, I
and
guess.
in a little bit, but they also then they look at it and like this is a cool idea. It's like,
Hmm.
hey, if I go and show these to people, I can explain to them. It's like, it's adds to that level of interest into what they've been doing and to tell their story a little bit.
And that's something
Yeah.
you've been doing for a few years, coming to Spacecom or Space
It
whatever
was
Space Fest.
Space Fest, yeah. So Space Fest was I went to in 2019 and 2021. And now Space Fest continues, which was last year and then this year. So actually, the three shuttle astronauts that I saw this past week are actually going to be there again. So
Hmm.
I don't have to get them, to sign it again. I was like debating. It's like, do it here, do it there. Is kind of they weren't busy at that moment, so it's like not that there was a long line of people and where I could go and talk to them. That was like the other cool thing about going to these things is being able to talk to them. Um, so it's fun. It's interesting stories. Um, things that I didn't know. Yeah, astronauts have interesting backgrounds. Um, and Susan Killian and Hoot Gibson have commonalities. They were both in the Navy. They both flew F-14s.
Ah,
Um,
cool.
So yeah, hearing Susan Killian, like her um first flight with her instructor, I don't know if like her checkout flight on the F-14, she had an engine go out and, landed the plane, everything was fine. But, I think even for the most experienced person flying an F-14, having an engine go out is, you know,
Not a
pretty high
good
pucker
day.
factor there.
Yeah. Yes.
Um,
Yeah.
and then let alone being on a shuttle and having your fuel cell go out.
Yeah.
Um,
Yeah.
I mean, there have been so many shuttle missions. It's like I didn't remember that story at all. Um, So yeah, and it was cool. Like I said, it wasn't a conference that I thought I would go to. I thought it was like all industry, but I met a lot of interesting people, including one of the organizers and one of the leaders, the current leaders of um, the National Space Society is Dr. Pascal Lee. And turns out that he had done the ANSMET mission 3 times. He
Awesome.
currently works on an analog environment in the Arctic Circle and somewhere up in an island in Canada, which is an analog for Mars that they've
Uh-huh.
been experimenting with. Um, and he told me he authored or co-authored one of the papers back in the 90s, the mid 90s, about lunar ejecta, like a meteorite hits the moon and and how or Mars, and that's where we're getting some of the meteorites from. Um, so I asked him if he'd be interested in interviewing he with us, and he said, "Yeah, probably if you can schedule it." So
Woo.
I'm gonna have to talk to Sue about arranging that
Wow.
at
Yeah.
some
Yeah.
point. Yeah, there's like a lot of
Hmm.
cool things like that. So
Wow. Yeah,
Yeah.
I really appreciate you bringing that angle. I kind of peer pressured him into showing and telling today. I'm glad we did because no, because not everything in the knowledge bolide has to be 100% meteorite. I mean, we like dipping our toes in the pond here and there on other things related to space exploration and stuff like that. So it's nice to have, maybe you won't refer to yourself as an expert, but our resident expert on space exploration and travel and stuff like that. It's good to have a go-to person because we really can't count on Boris for anything. So. And I do want to say, Bruce, thank you very much for your support. You are a paid member, and I definitely appreciate it as well, man. Thank you. Pat, would you highlight my camera for me, please?
Yes, let me find you. There you are.
This is Moldavite that Sue had out, so I figured I'd just take the chance. Is this sold or being sold, selling? Or are you listing it or?
Um, it is for a geologist who has had a great career and is leaving the country, and his assistant wants to buy him some Moldavite, some
Oh,
Aubrite, and some of our unclassifieds.
that's super
Awesome.
cool.
So yeah, she wanted to see all the Moldavite next to each other. She's like, I can't get a sense of how dark green some of them are
Yeah.
without seeing them next to the other ones. So she's like, can you just take all your Moldavite and like take a picture of it together? So I'm like, sure thing.
Yeah, this one, the Moldavite does show a lot of differences and variations in them. Like this one has long striations in it. This is another one that has long striations in it.
Mm. She did ask a question asking like the darker the green, the better, right? And I didn't know how to answer that because I actually kind of
No,
like the light green ones.
yeah,
It's all over the map, and these thinner pieces show a lighter green color. The thicker ones will be
whoa,
darker green. Uh,
That
but
one's very weird. It's like a
that is a
yeah.
yeah,
really cool
I
shape.
love that one.
I didn't know how to compare to like I don't know like a piece of pasta or something. Like it's just weird shaped.
And can you see the bubbles go
Yeah.
inside?
Mm-hmm.
Yeah, so this is a cool piece of
I think that's the heaviest one.
Moldavite. Hey, I just realized, Anthony, weren't you supposed to show us some wire wrap stuff? Or because I think you cheated us, man. Um,
That
when you look
wasn't
at,
on my agenda, but I can show you it if you want.
no, you missed your chance, dude. Sorry.
I wasn't going to
Um,
show you anyways.
good. I didn't want to look at it, man. Take your wire wrap and go. This is one thing that, and I don't know a whole lot about Moldavite, but I know like this is a very nice piece to have because you don't see any broken, shiny edges whatsoever. It's basically 100% intact. This one is not. This one, as you can see, as I'm rotating around, you see a bunch of shininess in it. Those are little broken bubbles. But like this right here. Yeah. Every single piece is definitely unique and individual. And I can feel the energy.
I strongly suspect these were ultra high grade Topher spin material from one of the Tucson adventures.
Yeah, back when Moldavite was affordable.
Yeah.
Jesus. Yeah. This one right here though, I absolutely love because I don't know what would go in what um how you have to throw this in the air or what has to happen in order for it to look like this when it's done. And a lot of Moldavite, you're going to see these almost like a what is it called? A complex crater that has like a jut in the middle sticking up. You can see this has like a moat and then a high mound in the middle. A lot of Moldavite will actually have that,
Mm-hmm.
which is, go ahead, Pat.
And a lot of the shapes too are from bubbles, large bubbles. The This one may have well have been from a piece that had an extended bubble
Yeah.
and then broke on impact. And all of the fine features, those are soil etching, and it etches differently because the Moldavite glass is not completely homogeneous. It has a lecherite streaky structure to it, and lecherite, and I'm sure I'm butchering the
Yeah,
pronunciation, is
lectularite. I believe. I know it's hard to pronounce, but yeah, it
yeah,
looks like little worms or something
yeah,
under
and
magnification. Yeah.
it's a higher pressure polymorph of quartz.
Very interesting, man. Definitely
Those,
appreciate it.
those are super nice pieces, Tober.
Yeah, I don't know why we still have these around, but they're still here. Um, this one, I don't know. This one looks just a little bit weird. Like it has all the bubbles are shiny on on the base of them. I thought
Yeah,
it was actually broken, but when I look at it now, it's not.
no, I don't think that's good because this is glass. It breaks with a conchoidal fracture.
Yeah.
And if you shine a light through that one, it will be quite
Oh,
translucent.
yeah, and that, Pat, thank you for feeding me my next line. Um, I'm a big fan of if I'm going to show something off, I want it to be a little bit educational. So one thing that you can see that we've been talking about is the structure of the glass. It's not surface, it goes through and through the entire piece.
Mhm.
That is Moldavite. You will not get that on fake Moldavite. See, on every single side, inside and out, you have the same structure and it goes through the glass. So when you look at it, it's not, you can see depth and complexity within the entire piece rather than just in a scraped up or etched up outside of a normal solid piece of glass, if that makes sense. I told you we were going to start with intelligence and it was going to be a sliding scale from there. And to put the bookend on the idiocy, I want to show you guys something that is stupidly beautiful. It's stupid and it's beautiful. And that was the exact words I used last night when my tattoo artist was done with this tattoo. I looked in the mirror, I laughed at it, and I said, that is stupidly beautiful. So I share with you my newest tattoo.
Toasty.
And butters.
Oh, yes.
It's a
Toasty
heart.
and
It's a
butters.
heart.
Yeah, so
That's cute.
I now have a toast for my Toasty the cat and Butters for little Butters. There's a claw mark and a paw mark.
Topher, twist your arm a little bit away from the light of the. No, stay close. Stay as close, but yeah, come back closer. Yeah, it's glaring. To twist, turn it toward
Yeah,
the hutch.
it's probably because this is not a photo.
There you go.
Well, they see
There
it.
you go.
Yeah, you had it. Oh, you had it. You guys can see the scratch on the bottom.
Yeah,
It's a good
Yeah.
tattoo.
that's a
Like
good one.
the application
Yeah.
is very well done.
Thank you. Yeah. So that's like the most stupidly beautiful tattoo I have because there's no reason for it whatsoever. But yeah, little toasty and butters are now memorialized on my body. And no, I'm not going to get meteorites down this arm. It's just going to be this arm. So. Yeah, and hopefully in the next couple of days the yellow will come out a lot more because it's all red behind it right now. But yeah, I've had Joe Tower do most of my work, and he's really, really good. So if you're interested in a tattoo and you're in Phoenix, contact me and I'll hook you up. If you're in Phoenix and you have what you think maybe a meteorite, don't bother knocking on my door. All right. All right. Now is the time everyone looks at the camera and waves, and we say goodbye, everyone. Thanks a lot, and have a great week. Bye-bye.